Now that we have reviewed exponential and log functions and laws, we can now start to look at the derivatives of exponential functions. So we are going to use first principles to just find that derivative. We won't always do this, but it's a good process to go through at least once. I have put a summary of all the derivatives on one page on the hub, so you can look at that and kind of have them all in one spot, but we'll just look at how they come up with this derivative. So we're going to use first principles. We're trying to find the derivative of y equals e to the x. So we want our limiting value as h approaches 0. F of x plus h would become e to the x plus h. F of x is e to the x, and that's all over h. I'm going to factor out the common e, so we get e to the h minus 1 all over h. Now e to the x does not depend on h, so I'm going to separate that. So I'm just going to put that out front. And we're just going to look at the limiting value as h approaches 0 of e to the h minus 1 over h. Now I can't evaluate that algebraically, so I'm going to do a table. And I'm going to approach it, I'm approaching 0. I'm going to approach it from the right side. So this is e to the h minus 1 over h. So let's start with 1. So I'm approaching 0 from the right, so I'll start at 1. When I put in 1, I get 1.72. Then I'm going to try 0.1. I sub in that value, I get 1.05. Then I'm going to get a little closer with 0.01. I get 1.005. I'm going to get a little closer with 0.001. And so I can see that as I get closer and closer to 0, let's do one more, we get a value that's getting close to 1. So it looks like from the table, the limiting value as h approaches 0 of e to the h minus 1 over h is equal to 1. So if we then go back to this, if this equals 1, then y prime will equal e to the x, and we just discovered that to be 1, so y prime is actually equal to e to the x, which is the same thing. Okay, so let's have a look at a few examples. So the derivative of e to the x is y prime is e to the x, and then just to expand on that, the derivative of e to the f of x is e to the f of x, so that stays the same, and then you multiply it by the derivative of f of x. Okay, so if I want to find the derivative of y equals e to the 5x, I'm going to leave e to the 5x the same, and then I'm going to take the derivative of f of x, which is 5. So the result is 5e to the 5x. If we have y equals 7e to the 5x, the derivative would be 7e to the 5x stays the same, and we multiply by the derivative of 5x, which is 5. So we get 35e to the 5x. C is a product rule. We've got 2x times e to the x. So we're going to have to use the product rule for this one. So y prime is derivative of 2x, which is 2. E to the x stays the same. 2x stays the same, and the derivative of e to the x is e to the x. So not really much to do here. You could take out a 2e to the x, which is common, and you could common factor that result. D is also a product rule. So we're going to take the derivative of x to the power of 4, which is 4x3 times e to the x, plus we'll leave x to the 4 the same. Derivative of e to the x is e to the x. And then we'll see what we can common factor. I see a common x to the power 3 and a common e to the x. So that will leave us with 4 in this bracket and x in that bracket. Okay, in this example we have the quotient rule, or you could make it a product rule if you wanted to. We could bring the x to the numerator. If it's pretty simple, I sometimes do that, so I'm just going to do the product rule. So derivative of e to the x is e to the x, and then we have e to the x times the derivative of x to the power negative 1, so that would be minus x to the power negative 2. Then we can factor out anything common, so I'm going to factor out x to the negative 2 and e to the x. So that will leave me with x in the first group, and then in the second group I will have a minus 1. F is an example of the chain rule. So we will bring down the 3, leave the inside the same. Subtract 1 from 3 is 2. Then we want to take the derivative of the inside. So derivative of 2 is just 0. So we'll do derivative of 3 to the negative x. Well, 3 to the negative x stays the same, and then we take the derivative of f of x, the exponent, so the derivative of negative x is negative 1. So I'm just going to multiply this together. So negative 3e to the negative x. What do we want to do here? We can multiply the 3 with the negative 3, and the e to the negative x has a negative exponent, so we can make it positive by putting it in the denominator. So sometimes we just want to clean it up a little bit. Okay, we will have some applications. So in these two questions you want to find the equation of the tangent to the curve. So the slope of the tangent will be the derivative. So we're going to find y prime. So it's going to be e to the negative x stays the same, and then the derivative of negative x would be negative 1. So we get y equals negative e to the power negative x. We want this at x equals negative 1. So that leaves us with negative e to the power 1. We don't really need that one, so that's our slope. So the equation of the tangent will be negative e x plus b. Then we want to put it through a point, so when x equals negative 1, y would equal e to the 1, right? Negative 1 times negative x is 1. So the point we are passing through is when x is negative 1, y equals e. So we'll put e here, x is negative 1, and b will work out to be 0. So the equation of the tangent line is negative e to the x. In example 9, similar, we just have to find the equation of the tangent, so we want to find the slope of the tangent first. So we want to find y prime. Derivative of 2 is just 0. And then we have a product rule. So we have derivative of negative x is negative 1. E to the x stays the same. Derivative negative x stays the same. Derivative of e to the x is e to the x. So let's multiply those first two together. We get that. We want to find that at y equals 0. We could factor that, but we're just subbing in 0, so we might as well just sub in 0. So negative e to the power 0 is going to be negative 1. And then 0 times e to the 0 is just 0. So the slope of the tangent line is negative 1. And then it's through the point x is 0, so we'll find the y that goes with that. And that's going to work out to be 2. So it's going to pass through the point 0, 2. So b is going to work out to be 2. So the equation of the tangent line is -1x plus 2.